Okay, hello to all the students and fellow colleagues. So today we'll be doing Snell's law. So the objective of this lesson is to define refraction, refractive index, and apply Snell's law. So we will start by assessing why the refractive index exists. So different materials have different chemical composition, and the interference of the chemical structure of the material against light traveling through the material determines the speed at which light travels through that material, and it's going to bend because it doesn't travel at its original speed. Okay, so let's start with air. Let's consider a few examples. So let's start with air. Air has a refractive index of 1, and also we should take into consideration that refractive index doesn't have a unit. It's a unitless factor that plugs into equations for application uses. And then water has a refractive index of 1.33. So water has more dense chemical composition compared to air. Okay, so because of the state also, the state at which air is a gaseous form and water is a liquid form. So light travels at slightly different speeds between the two. Okay, so we'll consider the angle at which the light travels through a media. So let's consider the first one as air and the second one as water. So say for instance, air travels through water and enters water at 30 degrees. So we have to calculate the second angle at which it will be traveling through water. So we should also consider Snell's equation for the mathematical application of such. So Snell's equation is n1 sine theta 1 equal to n2 sine theta 2. Okay? So we will take one medium as 1 and the other as 2 for both the refractive index and the angle at which it travels through that media. So considering what we have just mentioned now, let's look at this. So we'll take water as the second media. So the angle at which light will be traveling in water from air will be theta 2, and then the angle at which light will be traveling in air will be theta 1. So in this scenario, let's just make it a 30-degree angle. So we're going to put the information that we have into the equation and manipulate it in such a way that the second angle at which light travels through water becomes the subject of the formula. So it should be clear. Let me come this side. So this is what we're going to do. This is theta 1, 30 degrees, and the angle at which light travels through water will be theta 2. So we'll put the information that we have into the equation. Okay, and then we manipulate it in such a way that this variable becomes the subject of the formula. So it's going to be an arc sine after plugging. So water has an index of 1.33. That's what we're going to put. And then air has an index of 1.00, and it travels through the air at 30 degrees. Okay, so we have manipulated the equation, and theta is now the subject of the formula. So you put this in a calculator and then you make it work for you. Just make sure that you type in correctly, and there's slightly bigger angle because the index is greater than the other one. Thank you.